And then there's contention. Contention isn't an out-and-out failure, and it's not intermittent or transient errors either, but it's a major cause of performance problems in shared storage environments, especially spinning disk-based shared storage environments. A good example is backup. Most organizations implement backup windows that stipulate the times of day or night, usually night, where backups are allowed to take place. One of the reasons for this is that backup applications can impact performance, usually because the backup needs to read all of the data on the system that it's backing up. Then it's writing this data to the backup target. This reading and writing of data is heavy work, both for the shared storage array and the network that the backup data is transported over. So you definitely don't want to be backing up a large database at the same time that the database is running business critical reports and queries. If your backup job and your database query are both contending for the same CPU, memory, and storage resources, then both operations will suffer. Sticking with databases, if a full table scan occurs on a massive database, this can have a significant impact on the performance of that database, as well as potentially the shared storage array that the database is on. And if that is a shared storage array and it's impacted, then so are all attached hosts. Both of these are examples of what we call noisy neighbors. Basically, in a shared storage environment where multiple systems and applications share the same storage array, if one system or application decides to play unfair and pushes the array to its limits, this will impact other systems trying to use the array, and all systems will end up contending for the same resources. In situations like this, usually nobody wins and everybody loses. Then there's heavily mixed workloads. Throwing your storage array anything and everything when it comes to workload patterns gives it a really hard time. For example, if the workload that you throw at your storage system is a nice sequential read workload, then the array will notice that and tune itself to perform in an optimal way to handle that kind of workload. But if you're throwing it read-write, random and sequential, small block, large block, low referential locality, pretty much everything in the kitchen sink, then your array will start to struggle, especially again if it's built around spinning disks. Arrays built on solid-state technologies like flash media can cope with this a lot better, but not spinning disk-based systems. A major cause of heavy workloads are virtualization technologies like VMware and Hyper-V. Each physical machine in this kind of a setup hosts multiple virtual machines, each virtual machine with its own distinct and identifiable workload. But these workloads are all thrown together and mixed together by the hypervisor so that once they hit the SAN or the IP network, they're all randomized and indistinguishable. So as far as the storage arrays are concerned, every ESXi or Hyper-V host is throwing them a whole load of massively random work, being a real pain in the neck for storage arrays really. And last but not least, on the topic of convention, is again the RAID rebuild. Wow, we've mentioned this guy a few times already, but time for one last mention. RAID rebuilds can get in the way of user workload. There's no two ways about it. User workloads need to access disk resources, IOPS, megabytes a second throughput and so on, and so do RAID rebuilds. When rebuilding a failed drive, a system has to read a lot of data from all of the surviving drives in the RAID set, and then write that new data out to the new drive that's replacing the failed drive. This not only consumes disk and drive resources, it also consumes bandwidth on the back end of the RAID set. Fortunately though, most systems allow you to prioritize RAID rebuilds. Slower rebuilds potentially interfere less with user workloads, but take a longer time to rebuild the RAID set, whereas faster rebuilds tend to interfere more with user workloads, but they get you reprotected faster. Make your decisions based on your particular requirements.